video is to provide a summary of the ways that exponents are to be applied. It is important to be able to understand what all the notation means. In a simple exponent, x to the fifth power, x is the base, the 5 is the power, base and power, and what it means is that it is x multiplied on itself 5 times. So in this case, you have to be careful to only apply the exponent to the base. X actually has an exponent of 1. It's understood as 1. The y has an exponent of 2. So we understand this notation as being xyy, not xxyy. I propose a 3-step process for understanding two terms being multiplied together, or even any number. This is the procedure that I recommend understanding. First, we factor. This is using the meaning of the exponents. The x is repeated twice and the y is repeated 3 times. So here, the understanding of the exponents is that we have 5 multiplied by x times y times y times y times 3 times x times. And then, based on the commutative property for multiplication that says that 5 times x is the same as x times 5, we can switch terms back and forth and pull all the numbers out front and put the letters together in alphabetical order to clearly see how to put these two terms back together again. And yes, right away, students can see shortcuts and want to jump into the shortcuts, but I strongly encourage them to keep doing this factor, rearrange, and combine for quite some time so that that is clearly in their minds when the next procedures get presented and they don't get things confused. So again, I have them factor, rearrange. Don't lose those negative signs. Those are important. An odd number of negatives makes this negative. An even number of negatives, they cancel themselves out. It becomes positive. Now here is where the exponent 2 is applied to the entire base being xy cubed. And so this whole term here is repeated. Then we factor. Then we rearrange, and last combine. So this actually is 4 steps. I want you to understand 0 and negative exponents. That's an important part of exponents. Here we understand 10 to the third is 10 times 10 times 10, which is 1,000. 10 squared is 100, and so forth. You can see the decimal moving to the left. And this is important here, that anything to a 0 power is 1, not just 10. Any number, any variable to a 0 power is just 1. But if you watch the pattern of the decimals, you would hopefully predict that now the decimal will be on the left, which it is. It's 1/10. And so forth. Be sure you study that pattern until it makes sense to you and you can see the logic of what happens when you have a negative exponent. And then there's another way of looking at these negative exponents. 1/10 is 1 over 10. Look, this number 10 is now in the denominator when it has a negative exponent. And this is 1 over 10 times 10, or 100. And this is 1 over 10 times 10 times 10, which is 1,000. Similar thing happens with any other number, 2 to the third power. By now you should be comfortable as thinking as 2 times 2 times 2. 2 squared is 2 times 2. 2 to the 1 is just 2. And then you start thinking, well, what's going to happen? It's a 1. Then 2 to the negative 1. The 2 goes into the denominator, and it now has a positive exponent of 1. Similarly, 2 squared with a negative 2 goes into the denominator as a positive. And finally, 2 to the third with a negative goes in the denominator as well, becomes positive. Not the sign of the number. So be very clear that a negative exponent does not make this 2 negative. This is still a positive 2, positive 2, positive 2. But because of the negative exponent, it belongs in the denominator. The negative exponent might be saying, I'm unhappy, I'm out of place, I'm upstairs, I should be downstairs. If that helps you remember. Okay, so here's some specific examples. Watch this negative 2 exponent on the base 3. It's the same thing as a 1/3 to the second power. But when the negative exponent is in the denominator, the opposite happens. It needs to go up in the numerator. So in this case, the x to the third power is perfectly happy where it is, but the y to the -6 is out of place. Now you'll recall that 4 over 4 is 1. X over x is 1. And using that fact, we can say that all of these 1's are just taking up space. They add nothing to the value when multiplying. And so we can remove them. So for that reason, identical terms cancel out as 1's. Here you see x divided by x. That's 1. It can be removed. Also, y times y is the same as y times y, therefore they cancel. And so with a pair of z's. Notice they cancel up and down, not side to side, because of this idea of 1. 4 times 4 is 16, not 1.